General requirements for field instrumentation. Descripts video. We explore the essential guidelines and standards for field instrumentation in industrial settings. We cover key areas such as flow measurement, level measurement, pressure and differential pressure instruments, and temperature measurement. Additionally, we delve into quality assurance, inspection, and testing procedures, ensuring compliance with international standards. Learn about material selection, protective coatings, nameplate details, and the importance of thorough inspection and testing to maintain the highest levels of reliability and safety in field instrumentation. This video will enhance the learning and competence of instrument engineers by providing them with a solid foundation in the principles and practices of field instrumentation. By understanding these critical requirements, engineers will be better equipped to design, install, and maintain instrumentation systems that meet industry standards and operational demands. This knowledge will contribute to improved system reliability, safety, and efficiency, ultimately leading to more successful project outcomes and professional growth in the field of instrumentation engineering. Whether you're an engineer, technician, or industry professional, this video provides a comprehensive overview of the best practices for field instrumentation. Design requirements. General. Manufacturers of instruments and instrumentation equipment must adhere to the approved list. All work should strictly comply with approved drawings and specifications. Any deviations require written approval before proceeding. Conflicts or exceptions must be reported immediately upon discovery and before installation. Identification tags must remain securely attached to the instrument during installation. Safety instruments. Safety-related instruments should comply with specific safety standards and have self-diagnostic capabilities. Tile 1 and higher initiators should have their own independent process tappings, impulse lines, sensors, utilities, etc. Intelligent sensors with 4 to 20 milliamps output signals are preferred for their lower failure rates and better accuracy. Accessibility. Instruments must be located for easy access and maintenance, following minimum accessibility requirements for operational attention or maintenance. Materials. All materials should be new, unused, and free from defects. Special attention should be paid to O-rings and seals to ensure compatibility with process conditions. Hazardous materials must be labeled and supplied with a Material Safety Data Sheet, MSDS. Brass or copper alloys and aluminum in contact with process fluid are prohibited. Material traceability and certification. Materials used must be traceable and certified as per the relevant standards. Hazardous area classification. Instruments must comply with hazardous area classifications relevant to their installation environment. Design life, availability, and reliability. The minimum design life for instruments is 30 years. Performance guarantee. All instruments and materials should be new, of the highest grade, and free from defects. The manufacturer must guarantee against defects for 12 months after the instruments are in service and repair or replace any defective parts within 1 week at no charge. Conflicts, deviations, and amendments. Any conflicts between specifications, data sheets, or standards should be referred for clarification. Vendors must obtain clearance before proceeding with manufacture or supply. The specification may be amended or updated during the project, subject to commercial settlement. EMC compliance. All electronic equipment should comply with relevant EMC standards for emissions and immunity. General instrument specification, technical requirements. General requirements. All transmitters must be provided with local indicators integral with the unit. The scale on linear transmitters must be in engineering units for all transmitters, except for level transmitters, which must be 0 to 100% of instrument span. The preferred transmitter must be of Smart Heart analog type, operating in 4 to 20 milliamps DC mode. High and low trips may be derived off the same transmitter signal. However, transmitters used for trips must be independent from any transmitters used for control, indication, or pre-alarming, high or low alarms. Transmitters for SIS applications must be CL certified, certified by TV. Where both process measurement and safeguarding functions are required, the ESD and ICS transmitters must be completely independent and cover the same process range where practical. Pressure and temperature ratings of the process-mounted instrument components must conform as a minimum to the rating of the process system to which they are connected. The transmitter housing material must be 316SS with isometric M20 cable entries. Primary isolation of instruments. Isolation must be provided for isolation of instruments from the main process lines. Isolation valves must be in accordance with the relevant piping specification and of a modular integral type design. The use of instrument manifolds or instrument multi-port valves for primary isolation is not acceptable. Instrument connection dimensions must be a minimum of 1/2 inch NPTF for threaded instrument connections and a minimum of 2 inch flanged for flanged instrument connections unless specified otherwise in the following sections, e.g. radar level transmitters, thermowells, external level chambers. Instrument process connection. Instrument process connections on the piping equipment must be provided as follows. PG PT DPT, 2 inch flanged, 1/2 inch NPT instrument connection. Thermowells, 2 inch flanged for class 900 and lower. DP type level transmitter, 2 inch flanged. Level gauges, magnetic. Level transmitters, guided wave radar type, 2 inch flanged on standpipe. Level transmitter, radar ultrasonic type, 4 inch or 6 inch flanged depending on application. Level switches, 2 inch flanged minimum. Standpipes, 2 inch flanged. Orifice with flange taps, 1/2 inch NPT, flange taps. Instrument transmission signals. Signal transmission between field instruments and remote control systems equipment, e.g. ESD and RTU, must generally be electric as follows. Analog transmitters, 4 to 20 milliamps, 2-wire, 24-volt DC, smart HART digital communication preferred. Control elements, 4 to 20 milliamps, 2-wire, 24-volt DC, smart digital communication preferred, power sourced from ESD RTU. Temperature element, other than temp transmitters, 3-wire PT100 RTD. Digital field instruments field switches, 24-volt DC powered from ESD RTU. Digital on-off valve. Valve open-close, 24-volt DC powered from ESD RTU. Solenoid sense for valve open-close control is dependent upon failure requirements versus switching requirements per application. Instrument air supply, minimum, 5.5 bar G. Normal, 7 bar G. Maximum, 10 bar G. The scales of instruments must be graduated in engineering units and must read as follows. Temperature, direct reading, pressure, direct reading linear, flow, direct reading, 0 to 10 SQRT extraction for DP flow transmitter, level 0 to 100% of instrument span, others, direct reading. General instrument specification instruments. General process flow measurement will be carried out using orifice plates with a differential pressure transmitter. Orifice plates must be concentric square edge type with a flange rating of min 300 carbur and 1/2 inch flange taps. The orifice material must be SS360L, NACE as a minimum, and the design and sizing must be in accordance with ISO 5167 Part 1. The minimum size of piping to include an orifice plate installation with flange taps must be 2 inch NB. Differential pressure measurement for remote transmission must use capacitance, diaphragm-type, electronic transmitters with a preferred range of 2500 mm. Restriction orifice plates must be similar to flow metering orifice plates in construction and sizing method, and the material must be SS36L and NACE. The design and sizing must be in accordance with ISO 5167 Part 1. V-cone flow meters must be considered where less straight lengths are required. They must be of the insertion top plate type with an accuracy of plus 0.5% of the full scale range and repeatability of plus 0.1% or better. Positive displacement PD meters must have high accuracy, a removable strainer with air eliminator, flange connections, and a turn-down ratio of 10:1. Ultrasonic flow meters must be spool type, inline, multipath inferential liquid flow meters with high accuracy. The electronic system must have the capability for flow compensation and provide output signals as specified. Rotameters must be of float type, magnetically coupled, flanged, and made of SS360L, NAE as a minimum. They must be mounted in a top-bottom orientation and sized according to the manufacturer's recommendations. Level All level instrument process connections on vessels must be 2-inch flanged and 300 Sarger as a minimum, with larger sizes for tanks using radar type. Instrument selection and installation must allow for removal and replacement without taking the vessel out of service. Instruments must have dedicated nozzles for connection, or standpipes may be provided if necessary. Each instrument must have full-bore isolation valves, and all externally mounted instruments must have 1-inch flanged drain and vent connections. Level gauges must be magnetic follower type, with external bar graph indicators, or, if unsuitable, armored gauge glasses. Reflex type gauges are preferred except for specific applications where through vision gauges are better suited. Level transmitters without moving parts are preferred. They must be mounted to allow removal without vessel isolation, normally using external chambers. Preferred types include float with magnetostrictive transmitter pickup, FMCW radar for storage tanks, and guided wave radar GWR type. The transmitter must include a digital local indicator, reading in percent level relative to the datum line, with an accuracy of 0.1% of probe length. Level switches must generally be float type with SPDT switches, either external chamber or top-mounted flange type. The enclosure must be SS316 weatherproof to IP65 and intrinsically safe to EXEA-IB. Pressure and differential pressure instruments. Pressure and differential pressure, DP transmitters must be smart type with both analog and digital signal transmission using HART protocol, non-volatile memory, and self-diagnostic capability. The transmitter must be intrinsically safe, EXIA-IB certified, with a minimum ingress protection rating of IP65. The sensor must be diaphragm capacitance type with silicon oil fill fluid, and the body and wetted parts must be SS316 as a minimum, with Hasteloi C measuring element diaphragm. Process connections must be 1/2-inch NPT-F, and electrical cable entry must be isometric. Transmitters must be provided with local digital indication, and the accuracy must be better than 0.075%. Pressure gauges, differential pressure gauges. Pressure gauges must be direct-mounted Borden tube type safety pattern gauges with shatterproof glass, solid front, and safety blowout discs at the back. Gauges must have SS316 cases and movements and be liquid fillable, with a minimum dial size of 150 millimeters. The accuracy must be 10.5% for DP gauges and 1% for pressure gauges of full-scale range. Over-range protectors and pulsation dampers must be provided as necessary. Relief valves. Relief valves must be selected according to Shell DEP 80.45-1010 and designed, constructed, tested, and marked in accordance with API RP 520, API RP 521, API RP 526, and API RP 527. Valves must have metal-to-metal seats, with resilient seat seals considered for specific applications. Bottom guides are acceptable only in special circumstances. Blowdown tolerances must be specified, and the total pressure drop between the source of overpressure and the valve inlet must not exceed 3% of the set pressure. Thermal relief valves for piping systems must be 1-inch by 1-inch flanged with minimum orifice area of 0.11 inch squared, D size. General instrument specification, INS temperature. Temperature gauges must be direct-mounted, bimetallic, all-angle gauges installed in thermowells with SS316 material for the sensor bulb and an immersion length suitable for the thermowells. The accuracy must be within -1% of full-scale range. Temperature transmitters must have a duplex 3-wire PT100 RTD for the temperature range of -200 degrees Celsius up to +400 degrees Celsius with SS316 sheath and mineral insulation. In general, transmitters must have integral temperature elements. Remote transmitters must be considered in specific cases, such as applications with high vibration, poor access, or in exposed locations where the transmitter needs protection from the sun by a sunshade. Where remote transmitters are required, the element head must be weatherproof to IP65 and certified to EXD. The RTD enclosure material must be SS316 with isometric M20 cable entry. The RTD sensor burnout response must be selectable as either upscale or downscale. The temperature elements to be used at the block valve stations on the pipeline must be clamped or glued to the pipeline to measure both metal and fluid temperature. The installation of the temperature element must avoid any influence of the ambient temperature, e.g., installation on the underground pipeline. Thermowells must be 2-inch flanged for class 900 and lower, and of the retaining flange type. They must be machined from bar stock base and made of SS36L, NACE as a minimum. Other materials must be used as dictated by the process conditions and as indicated in the instrument datasheets. Thermowells must be designed to withstand hydrostatic testing conditions and must have wake frequency and stress calculations provided in accordance with ASME PTC 19.3. The thermowell immersion length must place the measuring element in the middle third of the pipe. Shorter immersion lengths may be accepted, where wake frequency and stress calculations limit the immersion length provided the required accuracy can still be achieved. Where thermowells are required in line sizes smaller than 4-inch NB, the thermowell line must be swaged up. Test wells must have a screwed plug and chain. Tube materials must be purchased to comply with the following standards and must be round and free of scratches on the outside diameter. The fitting supplier should confirm the maximum allowable hardness of the tube. The tube material must be stainless steel 33116L with a minimum molybdenum content of 2.5%, seamless and drawn to ASTM A269 in a solution treated annealed condition, and with a maximum hardness of RB80. Stainless steel tubing must be clearly marked at intervals along its length bearing e.g. ASTM A269 grade size and molybdenum content. The tube must be externally protected with PVC sheath. Tubing for use on sour surfaces must conform to NACE MR75, latest. Standard stainless steel 360L tubing sizes must be as follows. However, larger wall thicknesses must be used where necessary to achieve the required pressure rating for the specific application. Instrumentation. Impulse tubing, half-inch dew .065, others, Wentz .049, vents and drains, Quarterman 0.35. The tube wall thickness, finish, and roundness must be checked against the fitting manufacturer's requirements. Carbon steel half-hard copper, an aluminum tube must not be used. Fittings. Compression fittings must be SS36L twin-ferruled compression couplings with 2 ferrules to separately seal and hold the tube, conforming to SS36L, ASTM 831, ASTM A276 to S316083 standards. Only twin-ferruled compression couplings, BS 2051 and BS 4368, with 2 ferrules to separately seal and hold the tube must be used. Manifolds. Instrument manifolds must be SS316L as a minimum and provided local to the instrument for the following services. 2-valve manifold for pressure gauges and pressure transmitters, 5-valve manifold for differential pressure transmitters. Instrument manifolds must be machined from a single bar stock of SS316 material. Valve seats, stem, and union bonnet must be of 17.4 pH material. Valve packing material must be in accordance with the design pressure rating of the service. The valve seats must be of hard, self-aligning with non-rotating tip. Protective shades, sunshades. All electronic instruments in tropical and subtropical areas exposed to direct sun radiation must be supplied with protective shades to limit zero-span shifts resulting from temperature changes, one-sided heating, and to reduce instrument housing temperature variations between day and night. Shades must also protect electronic instruments from condensation during heavy tropical rains. General Instrument Specification, Quality Assurance, Inspection, and Testing. General Requirements. All instruments must be subjected to quality assurance, inspection, and testing processes to ensure compliance with the specified requirements. This includes design verification, functional testing, and certification to confirm that the instruments meet the performance standards required for their intended applications. Inspection and Test Plan, ITP. The vendor must provide an inspection and test plan, ITP, for all instruments supplied. The ITP must detail the inspection and testing procedures, acceptance criteria, and documentation requirements. The ITP must be approved by the purchaser before the commencement of any inspection or testing activities. Inspection. The vendor must carry out inspections at various stages of the manufacturing process to ensure that all instruments conform to the specified requirements. This includes inspection of raw materials, in-process inspections, and final inspections before shipment. Inspection records must be maintained and made available to the purchaser upon request. All instruments must be subjected to functional testing to verify their performance under specified operating conditions. This includes calibration, accuracy tests, and any other tests necessary to confirm that the instruments meet the performance standards specified in the datasheets and specifications. Test reports must be provided to the purchaser for review and approval. Non-destructive examination, NDE test. Non-destructive examination, NDE, tests must be carried out on all critical components to ensure their integrity and compliance with the specified requirements. NDE tests may include radiographic inspection, ultrasonic testing, magnetic particle inspection, and dye penetrant testing, as applicable. The results of the NDE tests must be documented and made available to the purchaser for review. Hydrostatic testing. Hydrostatic testing must be performed on all pressure-containing parts to ensure their integrity and compliance with the specified requirements. The test pressure must be 1.5 times the design pressure and held for a minimum of 30 minutes. Any leakage or pressure drop during the test must be investigated and rectified before retesting. Test certificates must be provided to the purchaser for review and approval. Electrical testing. Electrical testing must be performed on all electronic instruments to verify their performance and compliance with the specified requirements. This includes insulation resistance testing, continuity testing, and functional testing of electronic circuits. Test reports must be provided to the purchaser for review and approval. Calibration. All instruments must be calibrated before shipment to ensure their accuracy and compliance with the specified requirements. Calibration must be performed using traceable standards, and calibration certificates must be provided to the purchaser for review and approval. Calibration records must be maintained and made available to the purchaser upon request. Factory acceptance test, FAT. A factory acceptance test, FAT, must be performed on all instruments before shipment to verify their performance and compliance with the specified requirements. The FAT must include functional testing, calibration, and any other tests necessary to confirm that the instruments meet the performance standards specified in the datasheets and specifications. FAT reports must be provided to the purchaser for review and approval. Site acceptance test. A site acceptance test must be performed on all instruments after installation to verify their performance and compliance with the specified requirements. The SAT must include functional testing, calibration, and any other tests necessary to confirm that the instruments meet the performance standards specified in the datasheets and specifications. SAT reports must be provided to the purchaser for review and approval. Documentation. All inspection and testing activities must be documented, and the results must be provided to the purchaser for review and approval. Documentation must include inspection records, test reports, calibration certificates, FAT reports, and SAT reports. The vendor must maintain records of all inspection and testing activities and make them available to the purchaser upon request. Certification. All instruments must be certified to confirm their compliance with the specified requirements. Certification must include material certificates, calibration certificates, test reports, and any other documents necessary to confirm that the instruments meet the performance standards specified in the datasheets and specifications. Certification records must be maintained and made available to the purchaser upon request.